So this is the third session on the topic of the cardioid, and today we'll look at the aspect of a cardioid being just a locus that is generated by a pencil of lines, and a pencil of lines is simply the point where lines meet each other. So if you have a one point where multiple lines cross each other or merge or might even diverge from, that point is a pencil. And then we shall also look at the cardioid as being as a caustic of a circle. And the caustic simply means that it is a point where you have a reflection of light at points, and the rays bouncing off a specific curved surface they do meet each other at a specific point, and that part where you have the bright spots is what we'll look at as being the cardioid. And then the third and last aspect of today's treatment is that a cardioid is an inverse of a parabola, and that is the inverse or the reciprocal of the radius of the parabola actually is the radius of a cardioid, and we'll show that and actually plot it. And then we have also done an experiment, an optical experiment, where we generated a cardioid on our cup of milk. So I hope you do enjoy and have fun. If you haven't subscribed to our channel, we do encourage you to subscribe. We do love math here. We play around with math. And yeah, please share if you can, and also like if you like our video. Thank you. Let's quickly go into today's treatment. So one thing we could look at when we look at the cardioid is that a cardioid can be generated from a bigger circle. And so if we create points that are equidistantly spaced from one another on the circumference of this bigger circle, and then one thing we could do is if we stop and then we pick the first point here, and then we draw a line from the first point to the second point, the second point to the fourth point, the third point to the sixth point, and the fourth point to the eighth point, all the way until we reach the half of the number of all the points that we have. And then after half, the next point, that is half the number of points plus 1, is going to be connected to the second point, and then half the number of points plus 2 is connected to 4. Like that, will create a pencil of lines, and that is going to play a bigger part in generating a cardioid. So let's observe what happens. Okay. So as we can see, we'll begin from here, the first point, and we've drawn the lines, and then you see at half we stop, and then from half we now begin connecting half plus 1 goes to number 2 here, and then half plus 2 is going to go to number 4, like that. And we've demarcated the blue just to give the distinction. So from half plus 1 all the way, so you see where these lines cross each other, it creates an envelope, and that envelope is a cardioid. Then we can continue. Another way is looking at it from a point where we have a light ray coming from, let's say, point number 1, and then we have that light ray reflected at all these points, and the mirror happens to be the tangent at all these points. So the reflection of light from each point demarcated by orange is going to also create a pencil of these rays, and this pencil of these rays happens to be a cardioid as well. And we're going to do an experiment where we pour milk in a cup, and then we see how that reflection, by putting a light source like a flashlight at one point, we will see a pencil of rays created that is a cardioid. So let's see how that happens. So I do have a flashlight, and as you can see, by me putting a flashlight right here, we are able to see a beautiful cardioid, and that is a concentration of those light rays. So you see the edge of the cardioid appearing very bright, right? Gets clearer there. I just have a second phone here that is providing the flashlight, and the rays of light bounce against the edge of the cup, and as you can see, the pencil of those light rays seems very distinct, and we see the edge of the cardioid. And we can, if I change the direction of my flashlight, that point shifts. If you see, change the direction, and we see a shift in the position of the cardioid. So this is a beautiful application of this cardioid treatment. Hope you can try it out. Just using milk in a cup, and the cup edge, or the inner edge surface of the cup, as the reflection of the light rays. Bye bye, till next time. Next, what we do is we are going to show that the inverse of the radius, looking at the polar equation, or the polar coordinates of a parabola, the inverse of the radius is the radius of a cardioid. So let's go ahead and see that. So what we see is that the radius of a parabola is 1 over 1 minus sine t, t being the angle. Cosine t multiplied by that radius means that is the x component, and the y component is 1 over 1 minus sine t sine t. And so we have, as you can see, we have a beautiful parabola. And then now if we go ahead and get the inverse of this radius is 1 minus sine t, right? So 1 minus sine t times cosine t, t being that angle, so that is the x, and then the y is 1 minus sine t times sine t, right? And then here we put from angle equals to 0 to 2 pi, right? And you're going to see a cardioid. This is an upward facing cardioid. And so if we now play around with the radius, so let's put A as the radius, that factor there, and we put A there, and then we create a slider so that we can vary that. And then here we're putting twice A, and then twice A. And then we create a slider now that slides between point, I think 1, let's do 1 to 2.5, right? So that now we can just allow it to play, and we see it vary. So let's play. So you can see it increases both the parabola and the hype. Do it change in size. But this is to tell you that the parabola, the radius of curvature, the radius of the parabola, its inverse is the radius of the cardioid. So that kind of sums it for us today. If you have any question, please feel free to reach out to us. We would love to talk to you and learn some more if you have some more ideas. So until next time, bye bye.